Hey everyone, I apologize for the baby noises in the background of the video, but my daughter's running around and doing all sorts of fun stuff. But I understand that several of you are having questions from 5.2 looking at the binomial probability distribution and how to compute some of these values and how to input them into the calculator. So I just wanted to give you a couple of examples as a for instance so that it's clear how this should work. So the problem with the the calculator actually has two functions that do calculations of binomial probability distributions. One is binom PDF, and you would use that when you want the probability for an exact number of successes. So if, for example, you want exactly 3 successes in your number of trials, you would use binom PDF, but that has to be when there's an equal to statement. Your calculator also has binom CDF, and that's what you would use if you have the probability that R is less than or equal to some value. So if it's less than or equal to, you use CDF. Now for any options that are greater than or equal to, or strictly less than, you actually have to do some conversions before you can use the binom CDF in the calculator. So for example, let's say we have a scenario where we have 15 trials. Let's say our probability of success on any given trial is 0.2 or 20%. And then let's say that we want to, in part A, find the probability of, let's say, exactly 5 successes. So for this one, because it says exactly 5, and since R, lowercase r, is the letter that we use for number of successes, I'm looking for the probability that R is strictly equal to 5. Now this will go directly into your calculator, into binom PDF, and you want to put in the N, P, R. So just think National Public Radio. Our N here is 15, our P value is 0.2, and our R value is 5. Now when we put that into the calculator, if we go ahead and run that, and there's instructions for doing that in the purple packet, but if I go to my distributions menu, down to binom PDF, 15, 0.2, 5, I end up with about 10%. So that would be the probability of getting exactly 5 successes. Okay. But let's say that I didn't want exactly 5. Let's say this time I want to find the probability of less than 8 successes, for example. So when it says less than 8, I'm looking for the probability that my number of successes R is strictly less than 8. And your calculator, being the finicky beast that it is, to use binom CDF, I have to have a less than or equal to here. A less than will not cut it. So I need to convert this so that there's a less than or equal to. Well, if I have less than 8 successes, then it must be the case that I have 7 or fewer, that my number of successes is less than or equal to 7. And then that's what I'm going to put into binom CDF. Again, it wants N, P, and R, so 15, 0.2, and 7, and that's what we would run. When we do that, binom CDF, 15.2, 7, we get about, well, if you round it to 2 decimal places, it's 100%. It's 0.9957, so about 99.6%. Okay. So if we have an equal to, we use PDF. Less than, we need to convert to a less than or equal to, use CDF. There's 2 more cases that you could run into. Your next case would be, what happens if we want to find the probability of, let's say, more than 4 successes. So here, when it says more than 4, that would mean that my R is greater than 4, so strictly more than. And here, not only is there not an or equal to underneath, but my inequality symbol is also pointing the wrong way to be able to use this in the calculator. So I'm going to use the complement rule from chapter 4. If I want the probability that R is greater than 4, that should equal 1 minus the probability that the opposite of this occurs. In other words, 1 minus the probability that R is less than or equal to 4. And you can see that those signs are strict opposites. This one's a greater than, the opposite then becomes a less than or equal to. Now that I have a less than or equal to here, I can go ahead and put this in the calculator. 1 minus binom CDF of n, which is 15, p, which is 0.2, r, which is 4, but don't forget to put in the 1 minus. So when we put that, when we put that into the calculator, 1 minus binom CDF 15.24, we get about 16%. And then our very last case that we could have is if we wanted to find, say, the probability that there are 6 or more successes. So since it says 6 or more, we're looking at a greater than or equal to 6. Again, if I want to put that in the calculator, I need to get this to flip around to be a less than symbol. But this time, when I try to use the complement rule and do the 1 minus, the opposite of greater than or equal to 6 is less than 6. But in order to use binom CDF in the calculator, this symbol needs to be a less than or equal to. So I have one more step. This piece, probability that R is less than 6, is the same thing as the probability that R is less than or equal to 5. Having fewer than 6 successes means that I have 5 or fewer. Okay. And so then that is what we put into the calculator. 1 minus binom CDF, 15.2, and 5. When we crunch that through, 15.25, we're looking at about 6%. So that's just a real quick video to hopefully help you out with some of the issues that you might be having in 5.2. If you have any additional questions, feel free to post them online on the discussion board, or certainly you can visit with the tutor in the Math Center, or you can come by my office during my office hours, and I'm always happy to help.